This delta x means very small increment in x. From that, we subtract the same function on the right hand side we have. Okay. Now, we divide this by delta x. And now we take limit delta x going to 0. Okay. Then once we evaluate this, we get certain answer. That answer is called as the derivative of y. It is divided by dy over dx. And for this, we give another notation. It is called as the f dash x. Right. So therefore, we get dy by dx is f dash x. If I take this fx function to be like this here, I take x squared plus 1 upon x like this. If we need to define dy by dx for this function, now this only behaves as fx here. Okay. Then dy by dx I can write like this. First, I told you here every x, right, we have to write as x plus delta x. So then every x we have replaced by x plus delta x. Here x is replaced by x plus delta x. Then here we have perfect squared plus 1 and whole thing divided by x we have replaced by x plus delta x. And then subtract the same thing, x squared plus 1 over x. Okay, that is this part I wrote. Okay. Now, I must divide this whole thing by this delta x. Now, of this whole thing, I have taken the limit delta x 0. Limit delta x 0. So, now using your limit knowledge, we have to evaluate this. Then we get certain expression that is going to be the derivative of this function. Okay, right. Now, last week we did the y plus sin x derivative, and I asked you to do cos x derivative. Okay. So, then today we will start the first one as y equals cos x. I asked you to do this as homework. Right. Right. Before going to this, you must first understand the product formula and CD formula. Product formula and CD formula. Right. So, I shall write the CD formula. There are some CD formula there, right? Right. So, then sin C plus sin D, right, we need sin C minus sin D, we need cos C plus cos D, we need cos C minus cos D, we need. Right. Tell me what is sin C plus sin D? 2 sin and cos here coming, right? What is this angle? Add these two angles and divide by 2. Okay. All right. So, then it is C plus D by 2. Here C minus D by 2. Correct, no? When this plus sign becomes minus, this cos comes here, sin goes here with the same angles, right? 2 cos C plus D by 2 sin C minus D by 2. Okay. That is how we remember sin C plus sin D and sin C minus sin D. Yes. For cos C plus cos D, okay, cos C plus cos D, sum of 2 cos, then the right hand side come in, here 2 cos and cos, cos come in. No? First angle is C plus D by 2, second angle is C minus D by 2. Then I think very easily you can remember, sin sum or sin difference right hand side coming in sin cos, cos sin. Cos sum we get only in terms of cos. Now, let us see cos difference. Tell me what is cos difference? Cos C minus cos D, it is 2 sin C plus D by 2, and what is second one? Second one also sin 2 sin C plus D by 2, and sin not C minus D, it is D minus C by 2, D minus C by 2, right. Okay. Remember this one, very important, may be confusing. Okay. And another 4 product formulae we need here. Tell me this 4 product formulae. 2 sin A cos B, 2 cos A sin B, 2 cos A cos B, 2 sin A sin B, 2 sin A sin B. To sin A cos B, what is this? To sin A cos B coming as sin A plus B plus sin A minus B, sin A plus B plus sin A minus B, right. Once this two interchange, that means cos come in here, sin come in here. Then what happens? Sin A plus B, this will be minus. Understand? Right. Sin A plus B minus sin A minus B. What is this to cos A cos B? Cos A plus B plus cos A minus B, right. Cos A plus B plus cos A minus B, right. Then what is this to sin A sin B? Cos A minus B minus cos A plus B, right. Yes, cos A minus B minus cos A plus B. This way, this formula we need, right. This all we learned in trigonometry lesson, right. Now, if we need to find a dy by dx for this function, how to write dy by dx? Limit delta x going to 0. What should be the first function here? Replace the x by x plus delta x, right. Cos x plus delta x minus what? The same function cos x, and we have divided this by what? Delta x, this way, right. Now, you have to consider this as your C and this as your D. Apply here cos C minus cos D, that means this one. All right, first apply that. First applying that, okay, we can do the derivation of this dy by dx. Right, now start. And take the answer for this derivative of cos x. Limit delta x 1 0. This delta x I can write as 1 over delta x here. Now, we can apply here cos c minus cos d. Cos c minus cos d, 2 sine at these two angles, x and x 2x plus delta x, 2x plus delta x, we have divided by 2. Then what happens? This we have divided by 2, we get x. This we have divided by 2, we get delta x by 2. Then we get what? X plus delta x by 2. And second one, sine d minus e by 2. From this we have subtract this, right? From x, right? Subtract x plus delta x, and this should be divided by 2. Previous bracket, these two we can cancel down, we get minus delta x by 2. Okay. This way we get. Now, we know, we learned in trigonometry, sine minus theta, the angle contains minus sign. This minus sign you can take out and you can write it as how? Minus sine theta. Using that, I can take this minus sign out. That minus sign I can take before this, because minus sign means minus 1, it is a constant. It won't change due to this delta x going to 0. Okay, due to this delta x going to 0. Therefore, I get here, I am going to arrange it like this. This minus sign I take out and I write that here, dy over dx, that minus sign I write here. Sin x plus delta x by 2 I write next. Okay. And now, after taking this minus sign out, we have sin delta x by 2 here. Sin delta x by 2 here. Okay. Now, here we have a product. This product should divide by delta x. That means, only one of these two we should divide by delta x, not both. I divide this by this delta x, writing it like this. Right? Okay. Now, another 2 is here. Okay. This way I can cancel down this 2. For a while I write this 2 here. People, now this 2 is this 2, right? Now, what I do is this. Here, this I divide by 2. And another 2 I write here. What happens? This 2 will cancel with this 2, nothing happens there. No change, you know. Why? This we divide by 2, meantime we multiply by 2. Then still we have delta x. Now, this 2 and this 2 we can cancel down. Okay. That is to say, right, here this 2 we can bring where? Here. Understand? Okay. So, therefore, I am going to write it like this. Now, the limit delta x equal to 0 I put here and here separately for this 2. Now, see, here when delta x going to 0, delta x by 2 also going to 0. Then, if I take this delta x by 2 as theta, here we have sin theta divided by theta. Delta x going to 0 means what? Half of that also going to 0, no? Then here we can write this delta x going to 0 as delta x by 2 going to 0. Then we get what? Sin theta divided by theta, theta going to 0. This is nothing but 1. Once this delta x here delta x going to 0, no? When this delta x going to 0, 0 divided by 0, 0 divided by 2 is really, here we have 0, no? 0 by 2 means 0. Then we have only sin x with the minus sign. Then we get minus sin x as a derivative of cos x. Understood? Huh? Right. Dy by dx equals minus put this delta x equal to 0, no? Then this place is 0. 0 by 2 is this is 0, we get sin x. Sin x, here we have 1. Then we get dy by dx as minus sin x. Here now we can put for this y. Y is cos x. D over dx cos x. Derivative of cos x with respect to x equals what? Minus sin x. This way we can take the derivative of cos x. Right. That is how we take derivative of cos x. It is minus sin x. Right. Hurry up. Those who finish this, go to tan x, y equals tan x as the next function. Take it. Put. Take y equals tan x as the next. Y equals tan x, take. Right, no? Yes. Finish this. Okay, now I will take tan x. Apply. Next one, y equals tan x. Sin x we found last week, now cos x, then tan x. Right? So, all for all trigonometric ratios we have to do sin, cos, tan, sec, cos x, cot. Do all. right? No? Yes. Now take y equals tan dx, third one, right? So then how to write dy by dx? Dy by dx equals, right, limit delta x going to 0. This x we must replace by x plus delta x and minus the same right hand side divided by delta x. Right. Now this tan I can write as sin divided by cos. This delta x I write 1 over delta x, right? Yes. One over delta x. This tan I can write sin divided by cos, sin x plus delta x divided by cos x plus delta x. Minus here sin x divided by cos x. This tan x we can write as sin x by cos x. Now here take the common denominator product of these two. Okay. Once you take product of these two as a common denominator, this comes here and this goes here. That is next line. Yes. dy over dx, limit delta x going to 0. One over delta x sin x plus delta x into cos x here. Minus cos x plus delta x into sin x divided by the product of these two, cos x plus delta x into cos x. Okay, now here if you take this x plus delta x angle as capital A, then this also A. Let us take this angle x as B, this also B then. Then see what you have here, sin A cos B minus cos A sin B. That kind of expansion is coming by what expansion? Sin A minus B, no? What is the sin A minus B formula? Sin A minus B formula we learned, sin A cos B minus what? Cos A sin B, no? Understand? This right hand side only here we have. Then tell me how to write this as in the left hand side. From the angle A, we have subtract angle B, sin A minus B coming to left hand side like that. Okay. Then we can write dy by dx limit delta x going to 0. Here sin from this a we have to subtract this b. Here x plus delta x, from that we have to subtract x, then this x and this will cancel and we get only delta x. That means this way I wrote this numerator. Okay. Now here we have delta x. By this delta x we have to divide. Then I divide this by delta x. And this denominator cos x plus delta x into cos x I write separate like this. Cos x plus delta x into cos x. This way I can write it. Okay. Please, sir? Same thing. For this only I wrote sin delta x, that divided by this thing, that is here we have. Okay. This by this delta x we have divide. I divide this sin delta x by delta x. Now this limit delta x going to 0, we can apply for this and this separately. That also I write like this. Limit delta x going to 0 like this. Right. Now see what happens. Sin delta x upon delta x going to 0. What is this? This is 1. Once you put delta x 0 here, we get cos x here, cos x here. What is that? Cos squared x. 1 over cos squared x. What is that? It is sec squared x. Understood? Right. Then we can write that answer too. This is 1. Delta x 0 means 1 over cos 6 into cos 6. Correct, no? Cos 6 into cos 6 means cos squared x. 1 over cos squared x means sec squared x. Then derivative of tan x is what? Sec squared x. Right. Then write down that answer. d over dx tan x equals what? Sec squared x. 1 over cos squared x means sec squared x. This way we can take the terms. Right. Those who finish this go to sec x. Sec x. Okay, no? Right. Now take the next one as sec x. Fourth one. Y equals sec x. Right, start. Y equals sec x. Hurry up. Right, start. Y equals sec x. Limit delta x equals 0. Sec x plus delta x minus sec x divided by delta x. Right, now, this delta x we write as 1 over delta x, open a bracket, sec how to write? 1 over cos, no? Yes, write down this as 1 over cos x plus delta x minus this sec x we write as 1 over cos x. Right, start. Dy over dx. One over delta x open a bracket, sec we write 1 over cos x plus delta x minus 1 over cos x. This way. Now, take the product of these two as a common denominator, then this cos x come in here, this cos x plus delta x come in here. Okay. Then numerator you get cos c minus cos d form, then apply that formula. I risk this, huh? Then we can write dy over dx limit delta x going 0 1 upon delta x, open a bracket, this delta x I wrote, take the product of these two as a common denominator, cos x plus delta x into cos x. This comes here, this comes here. Right. Now take this x as your angle C, this x plus delta x as your angle D. There you have cos C minus cos D. Then cos C minus cos D formula over there we have after that. Right. Then keep simplifying, take the answer. You must get the answer for this sec x. What sec x tan x? You must get the answer sec x tan x. Good. Right. Take that. cos C minus cos D. What is that? 2 sine. Look at that. Cos C minus cos D. 2 sine at these angles and divide by 2. What do you get? X. And x 2x divided by 2 means x. Now the delta x there. That also we have divided by 2. Then what do you get? X plus delta x by 2. And second one, sine D minus C divided by 2. D means this, right? This minus this, what happens? X plus delta x minus x means this x and this x will cancel, then we get only delta x, but that should be divided by 2 because D minus C divided by 2, no? Delta x by 2. We have this way. Right. Now, arrange it like this now, dy over dx. By this delta x we have divided this. Since here we have a product, only this or this we have divided by delta x. I divide this by delta x. Then I write it like this, sine delta x by 2 divided by delta x. Right. By this delta x I divided by this. Okay. People, now this 2, if I write that 2, people, I must write it here, no? Once I bring this 2 here, I can write it here. That means above this line. That 2, of course, we can bring where? Here, no? How? If I divide this by 2 and to cancel down this 2, I write here 2. This 2 and this 2 we can now cancel down. That is to say, this 2 come into here, no? Right, then I write that here. Okay. Now, here we have this term and this term, right. So, now I write next one this, sine x plus delta x by 2, sine x plus delta x by 2, okay. And here cos x plus delta x into cos x. Right. Now, this limit delta x equal to 0 I apply for this, this and this separately. Then evaluate, we get the answer. Right. Limit delta x equal to 0. First I apply for this numerator this way, and then denominator like this, and here. Okay. Delta x equal to 0 means this is 0. We get sin x. Delta x equal to 0 means this is 0. We get cos x here and cos x here. Delta x equal to 0 means this is sin theta over theta. This is 1. Yes. Then we get the answer. Here sin x, here cos x into cos x. And this is now 1. Okay. Now, our y is sec x, then I write it here dx. People, now this sin x and this cos x, when you take together, sin x by cos x, but tan x. This cos x is now 1 over cos x, cos x, 1 over cos means sec, then we get what? Sec x and tan x, sec x tan x. This is the derivative of sec x. from this column to this column, from that to this. Right, another two more we have, cot x and cosec x. Right, take this next one as cot x, y equals cot x. Now 5, no? Y equals cot x, take. Y equals cot x. Cot x derivative is minus cosec squared x. See whether you can get it, minus cosec squared x. Cot x derivative is minus cosec squared x. See whether you get this. You can write here dy by dx. Limit delta x going 0. Here cot x plus delta x minus cot x. Divide by delta x like this. Now write down this cot, write down this delta x as 1 over delta x. Cot we write as cos by sine and keep doing this. You must get minus cosec squared x. Right. Shall I erase this now? Finished writing this? Okay, now dy over dx. This delta x I write as 1 over delta x. open a bracket. This cot and this cot we write. Cot means cos by sine, no? Cos x plus delta x divided by sine x plus delta x minus cos x over sine x. Right. Now, here take the product of these two as common denominator, then this sin x come in here, this sin x plus delta x come in here. Yes. Now, then do this dy over dx. Like this. Then this sin x come in here. This come in here. Now, here if I take this x as angle A, here also we have A. If I take this x plus delta x as angle B, here we have angle B. Then see what we have here, sin A cos B minus cos A sin B. That expansion is coming by what? Sin A minus B. Understand? Sin A minus B. Sin A cos B minus cos A sin B. That expansion is coming by sin A minus B. Then how to write the numerator? Sin x minus what? X plus delta x coming. Write down that. Sin A minus B, x minus x plus delta x, like this, divide by sin x plus delta x into sin x. This way we have. Now, when you simplify here, this x and this minus x we can cancel down, but this delta x will be minus. Then here we get minus delta x, right, as the simplified answer inside the bracket of the angle. There you have, people, sin minus delta x, right. This minus sign you can take out. Reason? Inside sign, if you have the angle with minus sign, that minus sign you can take out. Minus sign means minus 1. Therefore, people, what I do next is this. This minus sign I take before, that I take here, because minus 1 is a constant, though this limit delta equal to 0 does not change that minus sign. Now, we have here sin delta x, that sin delta x I divide by this delta x, like this. And now, this one we have 1 over sin x plus delta x sin x. Now, this limit delta x on 0 I apply for this and this separately. Yes. This way. Now, here minus this is 1. Once you put delta x 0 here, we get sin x and here sin x, sin squared x. No? Yes. 1 over sin squared x. You know 1 over sin x is cosec x, sin squared x means cosec squared x. So, we get what? Dy by dx is cosec squared x with minus sign before minus cosec squared x. That is the derivative of cot x. Right. Therefore, you can write derivative of cot x with respect to x is minus cosec squared x. Right, no? Yes. Another one more, sixth one. Cosec x is the next one. Cosec x. Cosec x root is what? Minus cosec x cot x. Correct. Take the next one. Number 6. A derivative of cosec x. Y equals cosec x. Right. Start. Write the definition and start. Right, now we can write dy by dx. Limit delta x going to 0. Cosec x plus delta x minus cosec x divided by delta x. This cosec we can write 1 over sine. 1 over sine x plus delta x one over sine x. dy over dx take here common denominator as the product of these two. Then the sin x come in here, sin x plus delta x come in here. Take this as u angle C, this angle as u angle D. Then here we have sin C minus sin D. Sin C minus sin D, here we have, okay. Put that 2 cos, right? 2 cos C plus D by 2, sin C minus D by 2. After that we are here. And take the answer. You must get the answer minus cosec x cot x. Hurry up, hurry up. You should know how to prove this all. Sometimes maybe asking at the examination to prove. One over delta x sin C minus sin D 2 cos. First add these angles and divide by 2. X and x to the x divided by 2 means x and plus delta x by 2. Second one is sin. C minus D, from this x we have subtract this, then we get minus delta x by 2. Subtract and divide by 2. Okay. Divide by this way, sin x plus delta x into sin x. Now, this minus sign I can take out and that I keep here, next line, right? dy by dx. Minus sign I keep here. There we have sin delta x. I write cos x plus delta x by 2. This one, and here sin delta x by 2. This delta x, by that I divide this. This 2 I can write here, that means I can write here, that 2 we can bring to what? Below this delta x, yes, like this. Okay. Now these 2 only we must write next, right, like this. Sin x plus delta x into sin x. right. Now this limit delta x equal to 0 we have to apply here. Okay. Then you can see here this delta x equal to 0, then this becomes sin x, here delta x equal to 0, this is cos x. What is this? This is 1. This is 1. Then we get dy over dx minus here cos x divided by sin x and into sin x and 1. Then this cos x divided by sin x, cos by sin is cot. Okay. Here we have 1 over sin x, 1 over sin x means cosec x. Then we have what? Minus cosec x cot x as the derivative of cosec x, correct? No? Right. Then we can write this gives us d over dx cosec x minus cosec x cot x. Right, now we took derivative of 6 trigonometric ratios. You have to remember them all, and you must remember meantime how to derive them like this. Right. So, now what is summary here? We come to summary. First one, d over dx sin x. What is the derivative of sin x? Cos x. Number 2, derivative of cos x minus sin x. Number 3, derivative of tan x. What? Sec squared x. Number 4, derivative of sec x, what? Sec x tan x. Number 5, derivative of cot x minus cos x squared x. Number 6, what? Derivative of cosec x, what is that? Minus cosec x cot x, correct? No? Minus cosec x cot x. Right, no? You can very clearly see there, if any trigonometric ratio starts from letter C here, cos, cot, cosec. For these trigonometric ratios, before their derivative, we have minus sign here, minus sign here. Remember that. When any trigonometric ratio start with C, they have minus sign for the derivative. Remember this all, right? Now, Yes, we will come to the next one this way. Y equals sin x. Okay. Now we found dy over dx here. Dy over dx. What is the answer? Cos x. People remember here, the right hand side letter, this only come in to the left hand side denominator. Okay. Then left hand side we have dy over this x means this one, the right hand side letter we get there. Okay. Now tell me, if we have this way y equals sin u, then what derivative you can write there? Dy over what? Du, this one only coming here. Then tell me what is the derivative of this? If we have here x, we could find dy over dx. Since we have u here, now we can find dy over du. What should be the answer? Cos u. Understand? Cos u. Why? There is nothing. If we have sin x, after derivative sin, we get cos x. Now, if we have u here, the answer should be cos u, right? Then left hand side you should have what? This y should come here, and the right hand side letter only come in with this d in the denominator dx. Like that here, if y equals sin u, what do you get? Dy over du is what? Cos u. Okay. Now suppose we have this way, is that d equals, right? I will take cos 6. Is that d equals cos 6? Then what derivative you can write? dz over dx. dz over dx. Right. dz over dx. Always the right hand side letter only come in, left hand side denominator with this d. Tell me, when you differentiate cos, what do you get? Come to here. When you differentiate cos, we get minus sin. Then tell me here what is the answer? dz over dx should be equal to what? Minus sin x. Why? Derivative of cos x is minus sin x. Then here we get minus sin x. Okay. Now suppose this way we have s equals tan y. S equals tan y. What derivative you can write? Yes. What derivative you can write here? S equals tan y. ds over dy. Understand? Okay. D and d we write here. For this numerator we write this. Numerator here we write the right answer later. Right. Tell me what is the derivative of tan? Look at this. Sec squared. No. Then what is the answer here? Sec squared y. Understand? Sec squared y. Okay. Right. Now suppose people this way. I come to this now again. We are given this way, x equals sin y, right? Then what derivative we can find? D divided by d what? X come in here, right hand side y come in here, dx upon dy we get. Tell me what the derivative of sin? Sin derivative is cos. We get what? Cos y, right? People now asking to find dy over dx. Now here we have what? Dx over dy. How do you read this one? Derivative of x with respect to y. That's how we read this. But now asking to find dy over dx. There is a relation between this dy over dx and dx over dy. You know people here, this way, if I write x upon y, a simple fraction, this I can write 1 over y upon x. Can we write it like this? 2/3 we can write 1 over 3 by 2 this way. Possible, no? Like that people, dy over dx we can write how? 1 over dx upon dy this way. Then by giving this, if you need to find dy over dx, you can't find that directly. Once you are given this way, you can find directly dx over dy. It is this. Now, if you need to find dy over dx, now you have to use this relation. Understand? Okay? Then putting that here, you can find dy over dx. First, we will take down that as a knot. Thereafter, we go for the inverse trigonometric functions. Okay? The derivative of inverse trigonometric functions. Write down as a knot. Okay, write down as a knot dy over dx equals 1 over dx over dy. Here we write to give this meaningful answer, this dx upon dy not equal to 0. Reason, if the denominator is 0 of a fraction, that has no meaning. Okay? Dx upon dy not equal to 0. That we write here to give you a meaning here, meaningful expression, right? This is another important result in this differentiation. Right, now write down next subheading derivative of inverse trigonometric functions. Write down derivative of inverse trigonometric functions. Right. Our first one is y equals sine inverse x. You know, if I write sine pi by 3, sine 60, what is this? Root 3 by 2, no? If we need to subject this angle pi by 3, we take the sine to right hand side as how? Sine inverse. Yes. Pi by 3 equals sine inverse root 3 by 2, like this, no? Similar one is here we have now. Then what should be this y? Y should be an angle. What should be this x? A real number lying between plus 1 and minus 1. Understand? Okay, why we told what? For any angle, sine value lies between minus 1 and plus 1. That's why. Now people, by this, you can bring the sine inverse to left hand side. Once you bring the sine inverse to left hand side, that becomes what? Sine. Then we get what? Sine y equals x. Okay? Alright. Then we get, this implies sine y equals x. Okay? Sine y equals x means what? X equals sine y. Okay? Then tell me, what derivative here we can find? Dx over dy we can write. Okay? Tell me, what is dx over dy? You know the reason why should we get here x and y. I told you always the right hand side letter only come into left hand side denominator with this d. Right? The left hand side letter only, here we have with this numerator d. Tell me what is derivative of sine cos. Then we get what? Cos y. Okay? You have to remember this all, right? Cos y. People, now we need to find not dx over dy, we need to find dy over dx. Then we go for this. Okay. Now start. Right. Dy over dx is equal to what? 1 upon dx over dy. This way I can write. Now I can put for dx over dy this cos y. Right. 1 over cos y. Right. Now this cos y I can replace by this way in terms of x. You know, cos squared y plus sin squared y equals what? 1. No? For any angle, cos squared theta plus sin squared theta, 1, no? Yes. Here, sin y equals x, then this should be what? X squared. Take that right hand side. Okay? Right. Now subject cos y. Cos y, when you subject, first bring this x squared to right hand side, 1 minus x squared, then take square root, then we have to put plus or minus, like this. Here we select plus sign. The reason, in the sin inverse x graph, in the principal part, the gradient is positive. Therefore, we take plus sign. So, then here for this cos y, we put this plus square root of 1 minus x square. Then we get the derivative of sin inverse x. Right. Then we get, therefore, dy over dx equals 1 over, we take plus sign, 1 minus x square. What is y, people? Y is this sin inverse x. Then we can write that result. D over dx sin inverse x equals 1 over square root of 1 minus x square. This is the next result. Okay, like this, take y equals cos inverse x and y equals tan inverse x. Y equals cos inverse x next. In the cos inverse x case, we take the negative sign. Similar steps come in, we take negative sign. The reason is cos inverse x graph, when we consider in the principal part, gradient is negative. You will notice dy by dx means the gradient of a function. Right? So, then gradient is negative in the cos inverse x graph in the principal part. Therefore, we take negative answer for this. And third one, take y equals tan inverse x. Start this now. I give you 5 minutes. Y equals cos inverse x okay. Y equals cos inverse x, I can write this one, bring this cos inverse to this side, then we have cos y cos y equals 6, right. Okay. Now, I can write this as x equals cos y, x equals cos y. Now, what derivative we can write? Dx over dy. The right hand side letter only come into left hand side denominator. What is derivative of cos? Minus sin with the y, minus sin. But what we need dy over dx. What we have? Dx over dy. Therefore, we can write dy over dx as how? 1 over dx over dy. It is minus sin y. Right. Now, we have sin squared y plus cos squared y equals 1. But we know cos y equals 6. It is 1. Then subject sin squared y. Take this right hand side, 1 minus x squared, then sin y plus or minus root 1 minus x squared. Now, we put that we are here, dy over dx, right, 1 over, here we have minus sin y plus or minus here, this. Okay. Now, by this minus sign, we must multiply this plus and minus both. Minus and plus make minus, minus and minus make plus. Then this will be minus and plus, no? Minus and plus means again plus and minus. Okay? Right. Then we get dy over dx is equal to plus or minus 1 over square root of 1 minus x squared. In cosinus case, people, we select this minus sign. The reason is we drew in trigonometry cosinus x graph. In that graph, in the principal part, the gradient of the graph is negative. Because of that reason, we select this minus sign for the derivative of cosinus x. Okay? Then we can write d over dx. Y means what? Cosinus x. This is minus 1 over square root of 1 minus x squared. Remember this, huh? Next one, tan inverse x. Yes, tan inverse x. Right? Bring this tan inverse to this side. Tan y equals x. X equals tan y. Now, what derivative you can find? Dx over dy. What is the derivative of tan? 6 squared, no? 6 squared y we get. Huh? Then what is dy over dx? Dy over dx is what? 1 over 6 squared y. Yes. 1 over 6 squared y. But people, you know, 6 squared theta we can write how? 1 plus tan squared theta. Then 6 squared y we can write as 1 plus tan squared y. Right. Dy over dx is equal to 1 over 6 squared y we can write 1 plus tan squared y. Right, then tan y is x, put here x, y tan inverse x, then we can write d over dx tan inverse x 1 over 1 plus tan y is x, this is x square. Then this is the derivative of what? Tan inverse x. Our derivative of tan inverse x is 1 over 1 plus x square. Right? Okay. Okay, now next one, write down derivative of ln x. Derivative of y equals ln x. Ln x means logarithm x to the base e. Right. Ln x means log x to the base e. You know what is meant by e? Exponential e. In the exponential function, that e is here e. Okay. Okay. When the logarithm we take, when the base of the logarithm is e, logarithm, the base is e, that we write as ln x this way. Ln x. Right. Now let us see how to take this answer. Y equals ln x. Okay. That means y equals log base e x. People convert this logarithm to index form. We learned logarithm. Convert this log form to index form. You know this log 100 to the base to 10. What is this? What is this? 2. Convert this to index form. 100. This base we take to write. No? This way we can write it. This is called as index form. Like that, tell me here. X equals e to the power y. Yes or no? This gives us x equals e to the power y. Right. Now, what derivative you can write here? Right hand side we have y, left hand side we have x. What derivative we can find here? Dx upon dy. Last week we learned e to the power something derivative. Ex derivative we found last week. We found, no? E to the power x derivative? Have you haven't? I think we found that. Yes. What is the derivative of e to the power x? What is the derivative of e to the power x? E to the power x, same. Then here we can write dx over dy. Here we can write dx over dy. Right? This right hand side later only come into left hand side denominator dx over dy. Derivative of e to the power something, last week we proved derivative of ex is same ex, same thing coming. Then here also when we differentiate this, we get what? Same e to the power y. Then dx upon dy should be what? E to the power y. Yes. But people, we need what? Dy over dx. What is dy over dx? 1 over e to the power y, right? This way. But what is e to the power y? E to the power y is what? X. Then we can put x here. One over x. But what is y? Y is what? Ln x. Then once I put here, we get derivative of ln x as 1 over x. Correct, no? Therefore, you can write the last result. Therefore, derivative of ln x with respect to x is what? 1 over x. Okay, remember these all results. Right, no? Yes. I think today we can come to the end of the first series, right? If so, I can start next week the forces lesson, right? Okay, no? Right. Now we will write next subheading like this. First complete this. Now can you remember all the results today we obtained? Then repeat. Derivative of sin x, cos x. Derivative of cos x minus sin x. Derivative of tan x, sec square dx. Derivative of sec x, tan x. Sec x tan x. Derivative of cot x minus cos x square dx. Derivative of cosec x minus cosec x cot x. Derivative of sin inverse x 1 upon square root of 1 minus x square. Derivative of cos inverse x minus 1 over square root of 1 minus x square. Derivative of tan inverse x 1 over 1 plus x square. Derivative of ln x 1 over x. Okay. Remember these all results. Right. Now write down next subheading like this. Derivative of a product okay. Now listen to me. Now in this case people we are supposed to differentiate when we have a product like this. Here take x cube into sin x. Here we have one function, it is multiplied with another function. Okay. In this case when you differentiate this, that rule we can prove, all the proof I am supposed to do at the end of this lesson. This is how we write the dy by dx. First function we write as the same, x cube. That one we multiply by the derivative of second function. What is the derivative of sin x? What derivative of sin x? Cos x. කවුදෝ නැති වුණා වගේ ඉන්නේ. Right. First function we keep as the same and it is multiplied by the derivative of second function. Put plus sign. And second function keep as the same. And now multiply that by the derivative of first function. What is x cube derivative? X cube derivative last week we learned. Take this 3 before and subtract 1 from the power 3. 3x, 3 minus 1 means 3x squared. Okay? This is how we take the answer. Then suppose instead of this x cube and sin x, I take two letters u and v. By following this, tell me how to find dy over dx. Yes? First function we keep as the same. It is multiplied by the derivative of second function. How to write the derivative of v? dv over dx. Understand? Okay? dv over dx. This notation dv over dx means what? Differentiate v with respect to x. Plus what? The differentiated function is we know. Now we keep as the same. Then it is multiplied by the first function which has not differentiated yet. What is the derivative of u? du over dx. Understand? This is the formula. Right? So then first we will write this down. Write down like this. Write down let y equals u into v. Let y equals u into v. U multiplied by v. Where u and v, where u and v are differentiable functions, differentiable functions. U and v are differentiable functions, differentiable functions of x. Write down then write down this result, this. Now I substitute for this y, d over dx, uv. Write down this result. Okay, no? Yes. Come to this first example. Y equals x cube into sin x. First function we keep as the same. It is multiplied by the derivative of second function plus differentiated function. Now we keep as the same and it is multiplied by non-differentiated function lit. Now take the first example. This. Hurry up. Okay, second example, this number 2. y equals 2 times Ex tan inverse x. Right, stop talking now. Now, we can consider this right hand side this way. First, I can take this 2 times Ex as your u function, this as your v function. That way we can do. We will do that way first. dy over dx. Our first function we keep as the same, 2Ex. Right. Derivative of tan inverse x, what? 1 over 1 plus x square. Multiply that by 1 over 1 plus x square. Now plus tan inverse x, the differentiated function we keep as the same. Now that should be multiplied by the derivative of 2Ex. Tell me people, how to differentiate R2Ex. Can you remember we told when we have y equals a times fx, a is a constant and the function as a product. When this a is a constant, we told the same a we have to keep as the constant a, and keeping that as the same we multiply this derivative of fx. Okay, we have to think like that. So last week we proved that product of a constant and a function, how differentiate the constant we keep as the same and it is multiplied by the derivative of the function. That way now you can differentiate this. 2 is a constant, 2 and Ex as a product, then keep this 2 as the same and derivative of Ex is Ex. Okay, then when you differentiate this 2Ex, 2 and Ex as a product, then keep the 2 as the same, derivative of Ex, what? Ex. When you differentiate Ex, derivative of Ex is Ex, then we get Ex here. This way we can take first method. Second method people, I can take it like this, y equals 2 times Ex tan inverse x. No, I take this whole thing as fx. Right. Now what do you have? Y equals 2 times a single function now. A function and constant when you multiply, how to differentiate? The constant we have to keep as the same and that should be multiplied by the derivative of the function. That way we can now think. Ex into tan inverse x product I consider as single function fx. Now what do you have? Constant multiplied by single function now. When the function is multiplied by a constant, how to differentiate? Keep the constant as the same and now multiply that by the derivative of the function. Now the second method is that. Once you take that way people, the same answer coming. Either way you can use, right. Then I have to keep, right, this 2 as the same. Now open a bracket. Inside bracket we are supposed to write the derivative of that function. Once you go to this function here, this is a function now. Now we have to find its derivative. Earlier we considered this product as one single function as fx. Now its derivative we need to find. Now once we go to that, I ignore this concept that we used as single function. Now I consider this as our u and this as our v. Okay. We need the derivative of this product. There I consider this as u and this as v, and now we differentiate this as a product. How? First function we keep as same, it is multiplied by the derivative of second function, plus second function we keep as same and it is multiplied by the derivative of first function. Understand? Okay. Then what do you get there? Ex we have to keep as the same. Tan inverse x derivative is 1 over 1 plus x squared plus what? Keep tan inverse x as same and derivative of Ex is Ex. This way we get. The same answer come in. Only thing is once you take these two out as common factor, that answer come in. Anyway, you can use in this case. Right. Take that now. Hurry up. Right, no? Right, people, now another question will come to this. Take this y x cube into ln x plus 1 plus x squared into tan inverse x plus 2 plus 3. Right. How to differentiate this now? We have to differentiate term by term. First, we have to differentiate this. Secondly, this. Next, this. Finally, this. Right. Now, let's see how to differentiate. Here, we have product u and v product. Apply u into v form here. Here also product u and v. This is u, this is your v. Apply that. Here 2 is a constant. Then keep it as the same and multiply by root of Ex. Here 3 is a constant alone. When a constant is alone, we know derivative is what? 0. That way we can do. Now start. Here and here apply u into v. Right. Take that answers. Right. Hurry up. Right. Others also start. If you can understand something, then do. At the moment, if you can do something, do that. Dy over dx. First, keep x cube. What is the derivative of ln x? 1 over x. Yes. Then ln x keep as same. Our derivative of x cube 3x squared. That's okay. Now come to here. This is a u function. This is a v function. Right. U function we keep as the same 1 plus x squared. Multiply that by a derivative of tan inverse x. What is the derivative of tan inverse x? 1 over 1 plus x squared today we learned. Now tan inverse x function we have to keep as the same. That should be multiplied by the derivative of 1 plus x squared. People tell me how to differentiate 1 plus x squared. 1 is a constant alone, 0, plus x squared derivative how to take? Bring this 2 before, subtract 1 from the power. It is 2x, right. Then 1 is 0, x squared derivative is 2x, right. Now come to this. 2 2 and ex as a product, constant and a function product. Then how to differentiate? That occasion when we have constant and a function as a product, the constant we have to keep as the same. Ex derivative is what? Ex, right. Plus now this 3 is a constant alone. What is the derivative? 0. It is 0. This way, don't go to simplify, we can take the answer. Right, we will take another one this way, y equals x squared tan inverse x sin x. 3 functions here we have. 3 functions as a product we have. Tell me how to use this product formula to get the answer. Here we think it like this. This x squared and tan inverse x we take as one function as u. This we take as another function as v. Then we apply u into v. First we keep this as the same and multiply that by the root of this, plus this as the same and multiply that by the root of this. Now start. Dy over dx. X squared tan inverse x. First function we keep as same. Derivative of sin x is cos x, right here. Now plus. The differentiated function we have to keep as same, that is sin x. Now that should be multiplied by what? Derivative of what? This. Derivative of this. Derivative of this. What is that? X squared into tan inverse x. Now we need to find the derivative of this. Now people, once you very carefully look at that, that also another product, no? We need to differentiate this product. Now we apply product formula for this separately, taking this as u and this as v. Am I correct? I must write here what? Derivative of this product, no? X squared into tan inverse x derivative we need. To differentiate this one now, again I can use what? U into v form. Take this as u and this as v and now differentiate that there. X squared you have to keep at same. Derivative of tan inverse x 1 over 1 plus x squared. Yes. Plus what? Keep the tan inverse x the same and derivative of x squared is 2x. Right. This way we can take that answer. Correct, no? Okay, in your tutorial, take question number 54, part 9. Question number 54, part 9 take, page number 6. Question number 54, part 9. Y equals x into sin x plus cos x into x cos x minus sin x. Right? Can somebody tell me how to give a start to differentiate this? Yes? First we take this as u, or this as v. Then apply uv. Or dy over dx. This function you have to keep as the same. Yes. X sin x plus cos x. Right? Now that should be multiplied by the derivative of this function, no? Yes. What is that? X cos x minus sin x. We have to find the derivative of this. Then first find the derivative of this, write that here. Secondly, find the derivative of this, write that here. When you find the derivative of this, that also product. That also a product. U and V product it has. Then when you need to differentiate this, follow again U into V form. How to do this now? Keep x as same, multiply that by the derivative of cos x. What is the derivative of cos x? Minus sin x, right? Keep x as same, cos x derivative is minus sin x. Then plus what? Cos x we have to write and derivative of x. What is derivative of x? Derivative of x is what? 1. Right. Now we differentiated this minus derivative of sin x. What? Cos x. Have you finished? No, not yet. We kept this as the same and only we differentiated this and wrote. Then we have to keep this as the same and multiply that by the derivative of this. Understand? Yes. Plus. Keep this as same and multiply that by the derivative of this. U into V, no? Right. Then it is x cos x minus sin x. Alright. Now that should be multiplied by the derivative of this. What is that? X sin x plus cos x. How to differentiate this, tell me? We have to differentiate this and we have to differentiate this. How to differentiate this? Again apply u into v form. X is u, keep as the same, right. derivative of sin x is cos x plus sin x function we have to keep as the same. The derivative of x is what? 1 plus sin derivative of cos x what? Minus sin x, minus sin x. This way we can take the derivative. Do not go to simplify here. We will discuss questions to get the last simplified answer after practicing like this. Yes. Okay, then we come to break. After break, we continue this. Subject in derivative of a quotient. Quotient means a fraction, right? Derivative of a quotient. It's a fraction. Quotient means a fraction. Now, I take this way a fraction, tan x at the denominator, numerator we have x square. Let us see how to differentiate this way a fraction. Quotient means a fraction. This is how we take the dy by dx. It has a fractional form dy by dx, right. First I will explain how to take the denominator of this dy by dx. To take the denominator of the dy by dx, square this denominator, okay, tan squared x or tan x perfect square, right. First the given denominator we have to square, that going to be the denominator of the dy by dx. Now I will explain how to write the numerator, right. Numerator we write like this. At the beginning of the numerator, this same denominator we write, and it is multiplied by derivative of the numerator, okay, 2x. Then we put minus sign. Then we take the other way. First we kept this denominator at the beginning of the numerator and differentiated this and multiplied, no. The differentiated one is this, no, first time. That we keep as the same, and that is multiplied by the derivative of denominator. What is the derivative of tan x? Sec squared x. This is how we differentiate the fraction, okay, right. This is a given question. Its derivative is square the denominator, that is the denominator of the derivative. Now numerator, the given denominator, not this one, tan squared x, not tan squared x, given denominator is this, that we write first, and it is multiplied by the derivative of the numerator minus what? Numerator we fixed the same, and the derivative of denominator we write next, okay. This is how we take. Then as a formula, if we write this, suppose this numerator function as u, denominator function is v, then tell me you are dy over dx. Yes, v squared, yes, v squared, v times derivative of u, no, outright du over dx. Sign is minus, right. Then secondly, yes, this is the one differentiated, no, here, that you keep as same, and now the one we did not differentiate is v, now it is differentiated, right. Remember, therefore the given denominator v square, and that is the denominator of the dy by dx. The numerator starts from the given denominator. This we keep into derivative of this minus this we keep into derivative of this, okay. That's how we take, okay. Then write down like this. This also we can prove. We will prove this later. Let y equals u upon v. Y equals u upon v, where u and v are differentiable functions of x. differentiable functions of x. Then dy over dx is. We will substitute for y, d over dx, u upon v. Substituted for y, v squared, v times du by dx minus u times dv by dx. Right, no? Yes. Right, after completing this, right, now take this question here. Y equals, take this example, x squared over tan x, x squared over tan x, take this one. Yes, take this one, x squared over tan x. First this denominator v square and write the denominator of dy by dx. Then the numerator of dy by dx starts from this given denominator tan x, we keep as the same, and that we multiply by the root of x squared, it's 2x, minus we keep numerator as the same and that we multiplied by the root of denominator. Okay, that's how we take. Okay, now take your tutorial. In the tut, question number 56. Take part 3, 56 part 3. Question of 56 part 3 take. Y equals x plus sin x divided by x plus cos x. Right, hurry up, start that, dy over dx. The denominator of dy over dx is the square of the given denominator. Square this, x plus cos x perfect square. Now numerator, the same denominator given we write at the beginning of numerator of dy by dx. Now it is multiplied by the derivative of this. Right. Tell me how to differentiate this x plus sin x, differentiate this and differentiate this. What is the derivative of x? Derivative of x is what? 1. Differentiate this 1 plus derivative of sin x cos x. Right. Now what is the sign? Minus. Then what we do? The differentiated function is this, no? Here. That we keep as same. Then that should be multiplied by the function, the denominator derivative. Okay? X plus cos x. A derivative of x is 1. A derivative of cos x is what? A derivative of cos x is minus sin x, right? 1 minus sin x. Therefore, remember the order. The denominator of dy over dx is the perfect square of this given denominator. Here. Then how to start the numerator of dy by dx? Write in the same given denominator at the beginning. That we multiply by the derivative of the numerator. Putting minus sign, keep the same numerator and multiply by derivative of the denominator. Okay. Right. Okay. Take 56 part 5. 56 part 5. Y equals sin x plus cos x. Divided by sin x minus cos x. Right. I take this. Yes, what is dy by dx? Right, square this denominator, that is the denominator of the dy by dx. Right. Now, say given denominator, this the given denominator we must write at the beginning of the numerator. Sin x minus cos x. Into what? We multiply by the derivative of the numerator. And we interchange. What? This we write as the same and that we multiply by the derivative of the given denominator. That's all. Very easy to remember. Right. What derivative of sin x? Cos x. Derivative of cos x? Minus sin x. What sign we have to put? Minus. Then the differentiated function is this, no? That we keep as same and non-differentiated function we differentiate. Right. Sin x plus cos x. The numerator multiplied by the derivative of this. What is derivative of sin x? Cos x. Cos x minus sin x. That means cos x plus sin x. Right. We will simplify later. Don't be hurried to simplify this. Right. Now take 56 number 14. 56 number 14 as the last part of this. Uh, 56 number 14. Right, take that. Y equals x times cos x plus sin x minus cos x. Right, start this. First, square the given denominator and write that at the denominator of the dy by dx. X cos x plus sin x perfect square. Right. Now we start the numerator of dy by dx by writing the given denominator, not this one, given denominator. X cos x plus sin x. Now that we multiply by what? Derivative of this numerator, right? Now within bracket I must write the derivative of this numerator. There we have to differentiate this and we have to differentiate this. Tell me how to differentiate this. It is now product u v form. X sin x, therefore we differentiate taking this as product u v form, u into v form. How differentiate product? First function we keep as same, multiplied by the derivative of second function, plus second function we keep as the same, it is multiplied by the derivative of the first function. Okay. Our derivative of sin x is cos x plus sin x function we have to keep as same. Derivative of x is what? 1. Another cos x. What is the derivative of cos x? Minus sin x. That minus and this minus plus. Right. Have you finished? No, not yet. Put minus sign. The differential function is this one. That we have to keep as same, and it should be multiplied by the non-differentiated function, the derivative of this. Okay, yes. Then we have write x sin x minus cos x, right? Now differentiate this one. How differentiate this? X cos x we have differentiate as a product. Okay, right. Take that. We have to keep this x as the same. Derivative of cos x is minus sin x. Then minus x sin x plus cos x we have to keep as same. Derivative of x is 1. Cos x into 1 means cos x plus sin x derivative is what? Cos x. Right. This all. Don't go to simplify here. Keep this. We will discuss some this simplification later. Right. Some more sums available in that. Do them as homework number 56. Right. Now we will move to next part. Okay, now see here. We are given a function like this y equals sin x, right? You know how to find dy by dx here. Cos x. That means after sin we have only x plus x. Now suppose in place of this x we have a function in x, not just x like this. I am talking like this. Something like this we have now. When we have only x plus x, we know the derivative of sin x is cos x. Now, in place of x, here we have a function of x, here x square plus 1. Let's see how to differentiate this. Here I take this way. This one I take as u. Okay. Then what do we have? Equals sin u. What is really u? U equals x squared plus 1. Now tell me, here we need to find dy over dx. Once you take like this, right hand side we have u, left hand side we have y. Then what derivative we can find? What derivative we can find? Dy over du we can find. Yes. Tell me what is dy over du? Yes. Sin derivative is what? Cos u. Right. Here, left hand side we have u, right hand side we have x. What derivative we can find? What derivative we can find? Du over dx. Du over dx. Okay. Tell me, what do you get when you differentiate this x squared plus 1? X squared derivative is 2x plus 1. 1 is a constant alone. 0. 2x. Now we need to find dy over dx, because we should be able to find dy over dx, because right hand side we have x, left hand side we have y, then we should be able to find dy over dx. People, we have a rule. That rule is called as chain rule. This way. Chain rule. The chain rule is this: dy over dx is equal to dy over du multiplied by du over dx. This way we have a chain rule. This is called as chain rule. You can very easily remember here, this du and this du, when we cancel down, dy over dx, the left hand side same thing we get. Now both this and this we have, dy over du is here cos u, right? For this I can write cos u. Du over dx we have here 2x. But now for this u I can put, what is u? X squared plus 1. Then I can replace this u by x squared plus 1. Then we get this. Okay. So therefore, most of the functions we get like this, we have to use a chain rule. Okay. Then we will write the chain rule. Write down heading as chain rule. Write down chain rule like this. Right, after writing the chain rule, take the first example like this. Y equals sin x square plus 1. This we take as u. Then we have what? Y equals sin u equals x square plus 1. Now this function we can differentiate. We can find dy over du, we get cos u. This function du over dx, we get 2x. Now use that chain rule, using chain rule. dy over dx equals dy over du multiplied by du over dx. We can remember this du when we cancel down we get dy over dx, the same thing left hand side. Substitute now. Dy over du is cos u multiplied by du over dx is 2x. But you are u x square plus 1, put that here. X square plus 1 into 2x. This is the final answer. Right, people, this way applying chain rule is not practical when we have a little bit complicated question. So therefore, we must have, without using the chain rule, how to take this answer quickly. We will come to that like this. I will take one example like this. To get this idea clearly, we will take one example. Now finish this, no? Yes. See here, this way. We have a function like this, y equals sin. Right, now stop talking. Sin. And here cos and tan x, here we have. Okay. Now suppose we need to come to this place of x. Right. Somebody is trying to come to this place of x starting from here. Right. Then this story we can really discuss this way. Suppose here this very beautiful princess. Yes. Now this princess is very beautiful. There is more demand. Right? A prince is trying on her, putting a line. Princess' father is a great king. He noticed this. Now this king jailed this beautiful princess in a remote place. What to do? No. Not only that, she is given security. This tan means the first security ring. Soldiers placed here. This is a tan. On this ring, there are some soldiers carrying weapons. Why? That brave prince, the king knows the brave prince one day will come to take this precious princess. Okay. Not only that, people, the king put another barrier like cos here. Another barrier is there. Carrying weapons, like this. Right? To give more security, another ring is placed. Right. Now this way, security is given. Now prince is coming outside this. Then tell me, what should this prince do to go to this place? First of all, the outer soldiers in the outer ring should be what? Destroyed. Then he fire to this outer ring soldiers. While he is firing with this outer ring soldiers, no any disturbances for inner ring soldiers and this princess. Understand? Then this firing means assume as a differentiating. Okay. Now first the prince should differentiate this. While the fight is going on with these outer ring soldiers, no issue to the internal anything. Firing means differentiating. Then first take this into your mind, sign only. Once we differentiate this sign, don't change anything here. Why? Once the fighting is going with this outer ring soldiers, no influence to this ring soldiers and the princess. Okay. Then dy over dx, how do? Right. Very first function is this now. Suppose he destroyed this all. Right. Secondly, this. Here, what is this? This. Third, this. Here it is this. Finally, this. Fourth one. Yeah. The prince should come here. Then differentiate. Okay. While the attack is going on with the outer ring soldiers, people, no influence to inner ones. Firing means assume as differentiation. Then dy over dx. Tell me, what is the derivative of sine? Cos. Cos. While we differentiate this, do we change anything here? No. Right. Cos tan x. Right. Now multiply. Then most outer ring soldiers now killed. Right. The princess is little bit happy now. Now what do you have? Second one. What do you do of cos? Minus sign. Minus sign. Minus sign. Once you differentiate this, do we change this? No. Once the fight going on with this, no influence to the other parts, right? Inner parts, right? Cos is minus sign tan x. Right. Then this also the prince destroyed. Right. Now again multiply. Now tan available. What will you do of tan? 6 squared x. Right. This also now okay. Now prince has what to destroy this now? No destroying. Not firing. He came to this x now. Then what we do? We differentiate. Derivative of x is what? 1. Alright. Like that, people, one after one we have to go inside until we meet that precious one. Neither. Okay. So once you differentiate a function, meantime do we change anything inside that? No. One after other we must go inside. No. Our boys, once you are having this kind of situation, don't be hurry. Reason? Reason? Some kings think that once the king does like this fool prince coming this way, taking and going away. That's a good advantage for some kings. Without giving anything, they can give that thing outside. Okay? Therefore, don't be hurry. Wait till your time comes. Right. Okay, no? Then shall we take this example? Alright, start now. Right, differentiate this. අහුන්නේ නැද්ද? අහුණා නේද? චූටි එකක් තියෙන්නේ. චූටිව වැඩි දැනෙන්නේ අහුවෙනවා කියලා. right. Right. Now, we'll take another example like this. Y equals sine squared x cubed. We need to differentiate this. People now tell me, if I write this function again, it's really this, no? Sine x cube perfect squared, no? Yes. Now tell me, where is that princess? කොහෙද ඉන්නේ බඩු කැල්ල? මෙන්න මෙතන ළමයි. දරුවෝ ඉන්නේ කොහෙන්ද? එළියේ. උඩ ඉස්සරෝම හම්බ වෙන ඔබ්ස්ටකල් එක මොකක්ද ළමයි? Square එක. First we have to differentiate square. Then he comes in. Second obstacle is what? Sine. Second we have to differentiate sine. Then he is here. Then what's the obstacle? 3. We have to differentiate 3 now. The power. Finally this. But order this power first. Secondly sine. Third this power. Finally this 6. Fourth one. Right? Let's see how to differentiate now. dy over dx. People, now we told when we differentiate something, anything inside that we don't change. Then assume this whole thing as capital X. Then what do you have here? Capital X squared. Tell me how to differentiate x squared. 2 comes before, same makes 2 minus 1 power. What do you get? 2 comes here. Do we change this one? No. The power is what? 2 minus 1. First one is that. Write down that. 2 sine x cube to the power 2 minus 1 is 1. Right. Right. Now the outer function we differentiated. Now that princess is here. Now he finds as the next obstacle what? Sine. What is greater of sine? Cos. Then do we change anything inside that? No. Cos. cos what? X cube into, now this 3, that means x to the power 3. What is the derivative of x to the power 3? 3x squared into what? Now x. What is the derivative of x? 1. Yes. Up to this way, you should be able to manage that. At a time, only one function we differentiate. None of the rest function inside that we don't change. Right. Okay. People remember next one. This come to this. Y equals sin x cube r root sin x cube root right. Right here, square root. What is square root? Square root means power half, no? Power half, yes, right. Dy over dx sin x cube power half here. Now tell me that princess should go to this place. What are the barriers? First is power half. Secondly, sine. Third is power 3. Finally, x. That's the order. Same thing, instead of this power 2, now we have power half. Even now, remember, if I have y equals root x, right, now listen to me. Y equals root x. Our root x is x power half. Let's see how to differentiate this. Dy over dx. Bring this half before. X, subtract 1 from this present half. Half minus 1, it's minus half. Okay, right. Dy over dx. Half x to the power minus half. Right. X to the power minus half means I can bring that to denominator. How? X to the power plus half. No? Yes. Half 1 over x to the power plus half. You know people, x to the power plus half means square root of x. No? This I can write square root of x. Then I can write this one 1 over 2 root x. Right? 1 over 2 root x. Right? So then for this y, if I put root x, I can write the result like this. When you differentiate root x with respect to x, right, because this y is root x, no? What is the answer we get? 1 over 2 root x. People remember this result. When we differentiate root something, root, when differentiate root, what is the answer? 1 divided by 2 times the same thing coming here. Here, same thing coming here. Same thing here we have. 1 divided by 2 times the same thing as the derivative of root. So then when we differentiate this, what do you get? Y equals root girl. What is the answer? Dy over dx. But 1 over 2 times same thing, root girl. Okay. Okay, therefore people, here, when we differentiate this root sign, we told the very first obstacle is what? Root sign. We have differentiated the root sign. Tell me what do you get? 1 over 2 times what? Same thing. First one. Then go to sine. What is the derivative of sine? Cos x cube. Next, x to the power 3. What is the derivative? 3x squared. Finally, derivative of x 1. Understand? That's how we do. Therefore, remember here in after, when we differentiate root, when we differentiate this root, what is the answer? 1 over 2 times the same thing. Understand? Okay? Then before going to this, take down this. Right? Take down this. And come to this result. Right. First take down this. When you differentiate root x with respect to x, the answer is what? 1 divided by 2 times same root x. 1 over 2 root x. Remember. When you differentiate root x, answer is 1 over 2 root x. Right. Okay, now let's see how to differentiate this. Right, now start to differentiate this. First root sine, then sine, then this power 3, finally what? This x. No? Now differentiate this. Y equals, right now. Differentiate this now. Y equals square root of sine x cube. First one is the root sine, second one is the sine ratio, third one is this power 3, finally this x. There's the order of differentiating. One after other we have to do this in order. dy over dx. Root sine, what? 1 over 2 times same thing. Over there we notice root x, when you differentiate, what do we get? 1 over 2 times same root x we get. Like that, when you differentiate this root sine, first we have to write 1 over 2 times the same thing. Sine x cube. Now this first function we have differentiated. That's okay. Now we have sine. What do we have? Sine? Cos. Meantime, do we change this? No. Once we differentiate this sine, do we change this x cube? No. Cos x cube. Right? Now this power 3, x cube, 3x squared, and x, it's 1. That's how we take. Understood? Right. Next one, take next question, this. This take. Tell me the order. First tan. Second one is root. Third one is sum. Dy by dx. What is the derivative of tan? Sec squared. Yes, sec squared. Sec squared what? After tan, what do you have? This whole thing, Sin x plus ex multiplied by. Second one is the root. We know what is the derivative of root? 1 over 2 times same thing. Yes. 1 over 2 times same thing is this. Multiplied by. Now we have sin x plus ex. Now what is the derivative of sin x? Cos x plus derivative of ex, same ex, right? Cos x plus ex. This way we get, right? Okay, now next one. Y equals e to power tan inverse root x. Tan inverse root x squared plus 1 take. Okay. Now tell me, that outer person should go inside this. Now tell me, what are the obstacles? One after other. First one is E. Then tan inverse. Then root sign number 3. Finally this fourth one. Okay. Now here e to power something we have. What is the derivative of ex? Derivative of ex is same, no? Then first we differentiate e. We assume this whole thing as x. Then here this takes the form what? E to the power x. You know, when you differentiate e to power x, what is the answer? Same. Then keep differentiating this. Hurry up. Hurry up. Start. Keep this aside. Yes, dy over dx. E, this is now x, ex is what? Same ex, no? Right. E tan inverse square root of x squared plus 1. Right. Multiplied by what? Now come to tan inverse. Oh, what is the derivative of tan inverse in the morning we learnt? D over dx. tan inverse x. What? 1 over 1 plus x squared. This x means what? This one. This one only we have to square here. Now apply here. Right? 1 over 1 plus what? After tan inverse, what do you have? This whole thing. Its perfect square only come in here. Okay. Here we have root. Once you square it, root will eliminate, no? Then what do you get? Only x square plus 1. But I write it like this. For easy understanding, I write it as x square plus 1 root perfect square. Alright. Tan inverse, this we differentiated. Now tan inverse differentiated. Now tell me what we have? We have root. What is the root of root? 1 over 2 times the same. Yes. 2 times the same. This. Multiplied by this also we did now. Now what do we have? We have what? X squared plus 1 derivative. What is the root of x squared? 2x. Root of 1, 0 because it is a constant alone. 2x only. This way we can take the answer. Now take your tutorial 57 part 14. Take 57 part 14. Y equals ln cos root x. Tell me order. First ln, number 1. Second is cos, number 2. Third is root sine, number 3. Fourth is x. Right, keep differentiating this. Start. What is the derivative of ln? What derivative of ln x? 1 over x. Yes, 1 over x. Right? Dy over dx. Right. Derivative of ln, log to the base e is this meaning of ln. Derivative of ln means 1 over the function after ln we have. What is that? Cos root x. Okay. This one you have to consider as x, capital X. Then this is ln x. What derivative? 1 over x. X means this part, no? Yes. 1 over cos root x. multiplied by. Now what is second function? Cos. What is the derivative of cos? Minus sine. Right. Minus sine root x. Now the third function, root. What derivative of root? 1 over 2 times same. 1 over 2 root x. Finally, derivative of x. What derivative of x? 1. Okay, this is how we take the terms. Right. Right, now take 57 part 1, 57 part 1 as the next. 57 part 1, take y equals 3 plus 4x divided by 2 minus x. Perfect square. Right, differentiate this. Hurry up, hurry up. The people absent, don't give up this one. Because the previous parts only you can't, but with this part you can manage. How to start this? Y equals three plus 4x divided by 2 minus x. First assume this as capital X. We assume this as capital X. Then we have what? X squared. Then what is first function we have differentiate? 2, no? How to differentiate x squared? 2 comes before x, 2 minus 1, no? Right. Dy over dx. Bring this 2 before. Same thing, this we want change. 2 minus 1 is 1 multiplied by. Now, by differentiating this, we came into this. We are inside this. Now we have to differentiate this. Now tell me people how to differentiate this. This is now quotient u over v form. Understand? This is now u, this is now v. U over v form now apply. Quotient, the fraction. How to differentiate the fraction? Yes. That we now follow. Square the denominator. Same denominator we must write here. Multiply that by what? Derivative of numerator. 3 plus 4x. 3 constant alone 0. 4x. 4 is a constant, x is a function. How to differentiate? 4 we keep as the same and it is multiplied by the derivative of x. What is that? Derivative of x is what? 1. 4 into 1. That's all. Minus what? The differentiated function 3 plus 4x we have to keep as the same. That we multiply by the derivative of this denominator. 2 is a constant alone 0 minus x derivative. What is the derivative of x? 1. Yes. All right. This way now we can do that. Okay. Now up to question number 59, you can do all the questions in the tutorial as homework. Page number 7, after question number 59, you can do all as homework. Right. Now we will take this. Take question number 61 in your tutorial. 61, first part, take. 61 part 1, hurry up. 61 part 1. Y equals sine inverse root x. What is the root of sine inverse x? 1 upon square root 1 minus x squared. Right. D over dx sine inverse x. 1 over square root of 1 minus x squared. People, this x mean this one here. It's a square only coming here. Right. Dy over dx. 1 over square root of 1 minus, what should we write? After sine inverse, what do you have? It's perfect squared, you must write here. Here. Root x to the power 2. What is root x to the power 2? The root will eliminate, we get only x. Okay? Right, no? Yes. Then I write that as x. Now, okay, this is differentiated, that is okay. Now we have root. What is the root of root? 1 over 2 root x. Multiplied by now x. 1. Understood? 61 part 7. Next one. 61 part 7. Y equals tan inverse xex. Y equals tan inverse xex. Hurry up. What is the root of tan inverse x? Root of tan inverse x? D over dx. Today we did this. 1 over 1 plus x square. X square means what? This one is x. Only come in here. 2 square. Then first one is tan inverse derivative, right? Dy over dx. 1 over 1 plus. What should we write? After tan inverse, what do you have? Here? That we have to square here. Here we have xex. Then we must write here what? Xex perfect square. Xex perfect square. Right. Now we differentiate tan inverse. Now we have differentiate this one. We must write here. Tell me how to differentiate this. Here we have product, no? This one you can take as your u function. This one you can take as your v function. U into v now we have. Product. How to differentiate product? U we keep, multiplied by derivative of v plus v we keep, and derivative of u. No? Right. Take like that. X we have to keep, that we have to multiply by derivative of Ex. What is the derivative of Ex? Ex. Plus what? Keep Ex as same, and derivative of x is what? 1. Yes. This way we can take that answer too. Okay, now number 61, there is questions to do as homework. Now come number 62. Question number 62. Question number 62. Take first part. Number 62, part 1. 62 part 1. Ramai pandangan. Y equals tan inverse square root of 1 minus cos 6 divided by 1 plus cos 6. Tell me the order. First tan inverse, then root, then this fraction. Understand? Right. First tan inverse, then the root, then this fraction. Keep doing this now. Hurry up. Dy over dx. What is tan inverse? 1 over 1 plus square. Square of what? After tan inverse, what do we have? It's perfect square. That means the whole thing we have to square. Since here we have root sign, once we square that, root sign will eliminate, no? Then what do you get? 1 minus cos 6 divided by 1 plus cos 6. Right, no? Multiplied by, now what do you have? Root sign. What is the derivative of root? 1 over 2 times same thing. 1 over 2 times same thing. 2 times the same thing this. Root 1 minus cos 6 divided by 1 plus cos 6. Right. Now what is next? Next is this. How to differentiate that? U over V quotient form. Right, fraction form. Right, hurry up. Square this 1 plus cos 6 perfect square. Same 1 plus cos 6 we must write. Then that should be multiplied by the derivative of 1 minus cos 6. 1 is a constant unknown 0 minus what is the derivative of cos 6? Minus sin x. Then the two minus signs together plus sin x. No? Right. Minus. Now the numerator function we have to keep as same 1 minus cos 6. That should be multiplied by the derivative of this function 1 0 cos 6 minus sin x. Right. This is right. Now we shall simplify this now little bit. We'll take the answer for this last answer. Yes. Okay, people, shall I change this here itself without writing more steps? Try to understand. Yes, you must write them. Here, look at this. In this fraction, I multiply numerator and this whole denominator. Both I multiply by 1 plus cos 6. Does this fraction change? No. Yes. Right? Then I erase this one and write. Right. dy over dx. This I multiply by 1 plus cos 6. This I multiply by 1 plus cos 6. What do you get? 1 plus cos 6. This one when I multiply by 1 plus cos 6, this 1 plus cos 6 here multiplier will cancel 1 minus cos 6 plus 1 minus cos 6 multiplied. Okay. Here look at this simplification. This minus 1 minus sin x. What do you get? Minus 1 minus sin x. Minus and minus plus what? Sin x. Here we get 1 into sin x. Now the sin x come in here. No? This and this sin x. Right. This minus sin, this 1 and this minus sin x. Minus 1 into minus sin x. Another plus sin x. Here we get plus sin x. Here also we get plus sin x. What do you get? 2 sin x. Now here, look at this. Cos 6 sin x product we get. Look at this. Minus minus plus. Cos 6 into minus sin x. What do you get? Minus cos 6 sin x here. Here we get what? Plus cos 6 sin x. What happens? Plus cos 6 sin x will cancel with minus cos 6 sin x. Then we get 2 sin x. Right? Divide by this 1 plus cos 6. Perfect square. Right. Now in the middle here we have this. Now I can apply this root for this and this separately. Is it possible? Possible, no? This root we can apply this numerator 1 minus cos 6 and denominator 1 plus cos 6. Then this part we can write as the numerator. What do you say? What is that? 1 plus cos 6 root I can write as the numerator. Yes, like this. Root 1 plus cos 6. And here 2 times root 1 minus cos 6. Is it clear there? Right. Then first write down that. Okay. Now tell me more simplifications. This cos 6 and this minus cos 6 we can cancel down. Then what do you have at the denominator? 1 plus 1. 2. Here we have 2, no? That 2 and this 2 you can cancel down. Okay? Or else you cancel down this 2 too. This one. Now this 2 will keep as half now. People, another simplification is here. Meantime, here 1 plus cos 6 power 1 here. Here we have 1 plus cos 6 power 2. Tell me, they are the simplification? Yes. One term of this 1 plus cos 6 you can cancel down. 1 plus cos 6, one term here. Then this 2 will cancel down, we can put 1. So clear? No? Yes. Now write down the terms we have. Here we have what people? Numerator 1, numerator 1 and 1 make 2. Tell me another simplification here. 1 plus cos 6 root means what? Power half. Now what is the power here we have? 1 plus cos 6 power 1. Then simplification. Tell me this and this how to simplify? This 1 plus cos 6 power 1 we can write how? Root 1 plus cos 6 into root 1 plus cos 6. Is it clear? Root means power half, no? Half plus half is 1 coming. Then this 1 plus cos 6 power 1 I can write how? 1 plus cos 6 root multiplied by another 1 plus cos 6 root. Is it clear? Then 1 here, 1 plus cos 6 root will cancel with this. What do you say? What do you say? Yes. Then what do you get here? This one become what? Power half. No? Right, power half. Or root. Yes. Now what do you have? Numerator sin x. Denominator what? This into, here also power half means root, no? Yes. 1 minus cos 6 root into 1 plus cos 6 root. Tell me how to write this product of two roots. This product I can write in this 1 minus cos 6 and 1 plus cos 6 as product, put in 1 root for them all. Am I correct? Then tell me what you get there. This root and this root we put as one single root. Inside the root we multiply 1 minus cos 6 and 1 plus cos 6. Tell me what we get when you multiply 1 minus cos 6 and 1 plus cos 6? 1 minus sin squared x. Yes or no? This way I am telling. Sin x here, put single root for both. 1 minus cos 6, 1 plus cos 6. I only say 1 minus cos squared x we get. Here 1 minus cos 6 into 1 plus cos 6. 1 minus cos squared x. No? 1 minus cos squared x. What is 1 minus cos squared x? Sin squared x. But that is inside root. What is that? Sin x. That sin x and this sin x we can cancel down. The R is half. Is it clear there? 1 minus cos 6 into 1 plus cos 6. What is that? 1 minus cos squared x inside the root sign. What is 1 minus cos squared x? Sin squared x. Now inside the root sign we have what? Sin squared x. Sin squared x root. What? Sin x. Then this is completely sin x. That sin x and this sin x we can cancel out. So clear? Yes. This is completely sin x. This 2 you can cancel down. What's the answer? Answer is half. dy by dx is half. People, this answer we can take in a very short form. I will discuss that also. දැන් ළමයි මේ differentiation වල කලින් ආපු නැති කට්ටිය ලබන්ස් දිනවල notes එහෙම හොයන්න ලෑස්ති වෙලා ඉන්න. නැත්නම් lesson එක අල්ලගන්න බෑ. Application of derivatives next time we can start. Now the theories of the fundamental of derivative now finished. Now do all the sums up to here. Right. Now the small part is available here. The alternative method to do this. Right. What is the question there? Y equals tan inverse root 1 minus cos x divided by 1 plus cos 6. Right. Now tell me, using half angle formula for this cos 6 to cancel this 1. There are 3 half angle formulae for cos 6. Cos 6. Tell me one. Cos 6 formula, tell me. Cos squared a by 2 minus sin squared a by 2, first one. Second one, 2 cos squared a by 2 minus 1. Third one, 1 minus 2 sin squared a by 2. Yes. I write here this one, 1 minus 2 sin squared x by 2. This one we write 2 cos squared x by 2 minus 1. Write down that. This way, right? Once you remove bracket by multiply minus and what do you get? Minus 1, here plus 1. These two you can cancel now. This and this you can cancel now. Okay. Now tell me what you get to numerator? Minus 2 plus 2 sin squared x by 2. Denominator also we have 2 cos squared x by 2. Then this 2 and this 2 we can cancel down. No? Then what do you have inside the root sign? Sin squared x by 2 divided by cos squared x by 2. Sin squared divided by cos squared is what? Tan squared. Then inside the root sign what do you have? Tan squared x by 2. Then what is the answer? Inside root sign we have what? Tan squared x by 2. Y equals tan inverse square root tan squared x by 2. Tell me the answer of this. Tan squared root. When you take root of square, what happens? The square will vanish. What do you get? Tan x by 2. Yes or no? Tan x by 2. Y equals tan inverse tan x by 2. What is this? Tan inverse tan x by 2. What? Tan inverse tan. What is it? X by 2, no? Yes or no? අයියෝ මට පව් ළමයි tan pi by 3 equals tan pi by 3. How to subject this pi by 3? Takes the right hand side. What? Tan inverse tan pi by 3. Okay. Angle, then tan inverse. What is the result? Same angle, no? Like that. Angle x by 2, tan inverse. What should be the answer? X by 2. Okay. Y equals x by 2. People tell me how to differentiate x by 2. X by 2 is half x, no? How to differentiate half x? Half is a constant, root of x is 1 half. Dy by dx is half. The same answer we give. Then up to the question number 60, not 60, yes. We can do these questions. Excluding 64, 65, excluding 64, 65 and 60, exclude these 60, 64, 65, excluding those, do up to number 76, do up to number 76. All the questions in this tutorial now you can do. Yes. Right, practice them and come to the class next day. Next day we start the, sometimes we start next day process in the first 2 hours, and after that I discuss questions in this. Right, okay. I will come to the end of the class today.